Hey everyone, welcome to Tutort Academy. So my name is Chirag Vaishnav, and in this video we will be solving a very interesting problem. The name is jump game, right? So when I first tried this problem, it was like a very tricky one to me because it was tough to understand. But when I got to learn the logic about this problem, it was like wow, because there are some things that you can think in your brain easily, but it's really hard to write it down in the code, right? But it's just that one hurdle, and if you learn to convert a thought process into your code, and that will be the point that you will be the best coder, right? So this is the thing that what I have learned from this question. I'm really excited to get you learn those things as well from this question, and I will try my best to explain you. So do watch till end, make sure to watch it till end, right? So before starting, I would like to tell you the flow of this video. So what will be happening is, first I will explaining you the problem statement, that what the problem states. After that we will be discussing what will be the logic that we have to discuss, that we will be building our code upon, and after that we will be discussing the code. That will be the most interesting part, believe me, right? So let's head over to the problem statement without wasting any further time. So here we are. So what you are given an integer array nums, and you are initially positioned at the first index, right? You are initially positioned at the first index. Now what you have to do, each element in the array represents the maximum jump length at that position. Each means each index, the position at each index, what it signifies is, it basically signifies the number of jumps that you can take from that position particularly. Return true if you can reach the last index, and return false otherwise, right? So this is the basic problem. Now what you have to do, you are given an array, suppose, right? So initially I am at 2, so I can take 2 jumps. So I from the first index I went to here, right? Now I can take 1 jump, and I can take 1 jump, right? So yes, I can get to 4, right? So this is the basic thinking behind it, right? So what basically you have to do there, because there are various problems of jump game as well. Suppose this is the basic problem of the jump game, that you have to reach the end. Now there will be one more modification of the jump game, that you have return the minimum number of jumps that will be there, right? So a lot of modifications of this jump game problem is there, because it is a very famous problem. So we will be discussing every aspect of that, so do not worry in that case, right? So let's head over to the PowerPoint presentation, so that I can help you explain it, right? So what was basically given is 2 3 1 1 4, let's say. This was our array, let's say. Right? So if this was an array, what you have to do, right? I am initially at this, right? My I is at this. Now I can take 2 steps, right? Suppose I take 1 step, I take 1 step, then I reached here, then my I is here, right? Now I can take 1 step, now my I is here. Now I can take 1 step, now my I is here, and I have reached the final position. So yes, what you have to do, you have to return true, right? But what are the things that you have to take care of, because it seems really a simple question, okay, that you have to move further, you have to move further, you have to move further, right? But what will be the minimum steps, if you can say, right? Because in this, what you have done, you have took 4 steps, let's say, right? One more way can be there for this question as well, because this question, in this question, what you have to simply return, you have to return if it can reach the end or not, right? So that is honestly not that easy as well, but not that tough as well. But a slight modification in this problem, and this problem becomes really tricky, right? Let's say I want to find the minimum number of jumps. What you have to do, you have to find the minimum number of jumps that are possible, right? Suppose I'm here at 2, right? So I'm having 2 steps, I can take 2 jumps. So I took 1 jump here. Now I can take 3 steps. So won't I directly get it to here? Won't I directly get it to here? So instead of 4 jumps, isn't your work done in 2 jumps? instead of 4 jumps, isn't your work done in 2 jumps, right? So that's the basic thinking. So what I will be trying to explain you is that what will be the minimum number of jumps, because if you are able to find the minimum number of jumps, then you will obviously able to solve this question as well. So what will be the minimum number of jumps, right? So for this, what you have to do, first of all, I hope that question is clear. So if it's not still, let me just explain you in detail that what it is. So question state that you are initially at this position, and you can take the number of jumps that are being written here. Suppose from this point I can take 2 jumps. For this point I can take 3 jumps, and for that you have to find that can you reach the end or not, right? So what you have to do, you have to simply take this problem as you have money in the bag and you can spend it, right? Suppose I'm having 2 rupees in my bag. Suppose I'm having 2 rupees in my bag, right? After that, so from this position, let me write the index 0 1 2 3 4, right? So if I'm having 2 and let's say reach will be the limit of the purse that I'm having, right? So initially I'm having this, so I'm at index 0 and I'm having a reach of 2, okay, that I can jump to. So what will be my maximum reach? My maximum reach will be index 2. I can reach index 2, right? And so if I'm like, and the steps that I will be having is that, okay, now initially I am having 2 steps that I can use, 2 steps to reach to the end, steps or jump basically, right? Let's say let's write it steps, right? You have to write the minimum number of steps that you can find the end, right? And at each step your degree will be changing, right? So this is your current reach and this is your max reach, right? So max reach is 2 in this case, right? So now I moved a step further here. So my step decreased to 1, right? And my reach is still 2, right? But here, if I use this, what will be the maximum reach? I am at index 1. I am currently at index 1 and I can take a jump of 3. So won't it will be 1 plus 3? Won't it will be 1 plus 3? So it will be 4. So from this index, my maximum reach, that from this index I can directly jump to 4. From this index I can directly jump to 4. It is possible. And my max reach is greater than the current reach, isn't it? My max reach is greater than current reach. So why not update it? Right? Now I move to this, right? Now I move to this, right? Now currently my so what will be my maximum reach here? 2 plus 1, 3. So is my maximum reach greater than my current reach? No. Is my maximum reach greater than my current reach? No. So there is no issue in moving to that. So what we will be doing is we will be moving further. So now it's 3 plus 1, 4. Is my max reach greater than the current reach? No, it's equal, not greater. It's equal to that, right? So no means there is no issue in reducing the steps here as well. Now here I have reached the final position. So we have to increase the step by 1, right? So it will be means it will be like we have reached our final position. So it simply states that what we will be doing is we will be containing a maximum reach, we will be containing a current reach, and we will be maintaining the number of steps that we are having, right? So it will be amount of purse that we are having. The number of steps are the amount of purse that we can spend on, right? So what you have to do at each index, what will be your maximum reach? The maximum reach will be current position plus the value that you are having. That will be the maximum reach or the final destination, the farthest destination that you can reach to, right? So you have to calculate that. And if you find a step that is greater than that, what you have to do, you have to do step minus and increase the number of jumps that you're having, right? So this was the basic intuition behind this problem. So I hope you like this explanation, right? So if you haven't, do ask in the comment section. I will definitely make you understand it, right? And I've tried my best to make you understand. Now let's head over to the code part. So in the code part, you can see the current furthest, right? So current furthest will be the maximum reach that we are having here. So maximum reach initially is 0, right? Now size is this, and what we will be doing is we will be iterating. Now if I is greater than current furthest, so in this problem what you have to do is you have to write, you have to return that if you are able to reach the end or not, right? So suppose I'm standing at index 1 and my farthest reach is 2. I'm standing at index 1 and my farthest reach is 2, and my farthest reach is 2 and my current position is less than that. The thing that I'm trying to explain here is that wherever I am standing, I am unable to reach there with the help of steps. Suppose I am having 0 steps and I am at index 1. I'm at index 1 and I am having 0 steps and I want to reach at index 4, let's say. So this is the scenario where I cannot move further. So in a scenario where we cannot move further, what you have to do, you have to return false. Else, what will be the possible new furthest? So possible new furthest was the maximum reach that we were calculating. And what was the maximum reach? Maximum reach was simply the position and the number at that position, or the value at that position, because that will signify the maximum furthermost destination, the position that we can get to, right? Now if my max reach is greater than my current reach, then what you have to do, you have to update it, right? And what you have to do, you have to update it. Now in the case of minimum jump, what we were doing, we were simply maintaining a count here and adding here. But in this case we don't have to do that. We will be if you want, write down in the comment section, we will discuss that as well. So in this problem, this is enough. What you have to do, you have to find maintain max reach and you have to maintain current reach. Now if at any index you are not able to go further, like I is greater than current furthermost, then you have to return false. Else you have to update the current furthermost with the max reach if it's greater than that, and return true at the end if there is no returning false in between, right? So this was the problem. I hope you got the solution right. So let me just submit it and see if it's working or not. And you can see it is being submitted. So it was lovely explaining you this question, because I have personally learned a lot out of this. So this was the video. So I hope you like this video. To give a thumbs up and make sure to subscribe to the channel, and if you're having any doubt, do ask in the comment section. I will definitely answer it. So thanks for watching, and meet you in the next video.